In the previous video, we connected the kit to the cloud through the IoT Core module. Next, we must make the functionality which handles the weather data and sending it to the device. Weather data must be fetched, cached, parsed, and converted to a clock hand position. To achieve this, we will have a look at cloud functions. A cloud function is a snippet of code that runs in a cloud when a trigger event occurs. In this video, we create this cloud function for the world clock. To learn more about cloud function, visit Google's documentation. The cloud function requires some source code to run. Microchip provides a Python script which fetches, caches, and converts forecast data, and it can be found on GitHub. Log into your GitHub account or create one if you don't have one. Navigate to the AVR Home Automation Weather Clock Cloud page on GitHub and fork the repository. This should create a copy of the code in your GitHub account. Google provides a module called Source, where we can connect our GitHub repository to the Google Cloud Platform. Click on Get Started, followed by Create Repository. Then Connect External Repository. Select the cloud project created in the previous video and GitHub as the Git provider. Select the forked Weather Clock Cloud project. Click on Connect Selected Repository and wait for it to connect. This might take up to several minutes. We will be using yr.no as the forecast service to provide data. Through an open API, we can fetch data for most locations on Earth. yr.no requires all data to be cached for at least 30 minutes before requesting new data. Cloud functions are serverless and have no notion of storage. In other words, we must create some persistent storage for the cloud function to store the cached data. Navigate to the storage module in the cloud platform. The store module uses the concept of a bucket, which is the collection of data. Press Create Bucket. Give it a name. The name is globally unique and can be accessed from any cloud project. Select multi-region and appropriate location. Leave the storage class on standard and press Create. Before we can create a cloud function with the uploaded code, it must be configured with our project's specific settings. Navigate to the forked repository on GitHub and open the config.py file. Press the pen icon. This allows us to edit the content. Enter the project ID, IoT Core region, IoT Core register ID, IoT Core device ID, and a cloud storage bucket ID. The yr.no location URL specifies which geographical location to fetch data for. Open yr.no and find the desired location, for instance London. Make sure the language is set to English. Copy the URL and add a /forecast.xml to it as such. This is the link we add to our config file. The temp max and temp min indicates the max and min temperature on the temperature scale. When you are happy with the configuration, press Commit Changes. All modules have been configured and we are ready to create the cloud function. Navigate to the cloud function page and click on Create Function. Give it a name, for instance Weather. Select HTTP as the trigger and uncheck Allow Unauthenticated Invocation. The source is Cloud Source Repository and the runtime is Python 3.7. The repository is the full name of the cloud repository we created earlier. The function to execute is fetch process send. This is the function which is executed when a cloud function is triggered. It is found at the bottom of main.py in the forked repository on GitHub. Click Create. When a cloud function has been deployed, you can trigger it by visiting the trigger URL. We have a URL which triggers the cloud function whenever it is called. Now to automate it, we can use the Google Cloud Scheduler. Navigate to the Cloud Scheduler page and click Create Job. Select the region and press Next. Give it a name, for instance Weather Scheduler. The frequency decides how often the scheduler executes the job. Enter the following in the frequency entry for it to run every 30 minutes. Select an appropriate time zone. Select the target as HTTP. The URL is the trigger URL of the cloud function we just created. Leave the rest at default. With the current setup, anyone with the trigger URL can invoke the cloud function, no matter who they are. In order to limit invokers to only the scheduler, we must add a service account. Cloud modules can be configured to only allow specific service accounts to access them. Go to the Service Accounts page of the Google Cloud. Click Create Service Account. Name it, for instance, Word Service. Note the Service Account ID as it uniquely identifies it. Press Create and add 2 permissions: Cloud Scheduler Job Runner and Cloud Functions Invoker. This allows this specific service account to run both the scheduler and invoke a cloud function. Go to the Cloud Functions page and check the checkbox for the Weather Cloud function and delete the All Users member under the Cloud Functions Invoker. This removes the unauthenticated user's ability to invoke the cloud function. Click Add Members and enter the Cloud Service ID of the account we just created. Select the role of Cloud Functions Invoker. Open a Cloud Scheduler page and edit the job we created. Press Show More and select Add OIDC token as the auth header. Enter the service account ID and press Update. To verify that everything is functioning correctly, press the Run Now button. We can see that the result column is now reporting success, indicating that the cloud function is running as expected. To verify this, navigate to the Cloud Functions page and select the weather function. By looking at the invocations graph, we can clearly see a spike indicating that the function was run correctly. All that remains is to add some code and configuration to the AVR IoT board. This is covered in the next and last video in this series.